When we plug in a table fan and switch it on, we connect it to the main electric supply. Where do we get this electrical energy? What is electric power? How is it transmitted? Electric power is what is given off when electrical energy is dissipated. It is given as the product of current and voltage. Electrical energy is generated from different sources such as hydroelectric power stations, where energy is stored in water; thermal power stations, where energy is stored in coal and oil; and nuclear power stations, where energy is stored inside the atom. We then transmit the electric power that has been generated over long distances from power generation stations to the consumer's point of views. You must have noticed high voltage signboards in electric transmission towers or poles. Why should we use high voltage power transmission? We can calculate the power loss in terms of voltage by applying this equation. If we keep high voltage transmission, we can reduce power loss. Power loss is inversely proportional to the square of the voltage. Hence, increasing the voltage decreases power loss. Therefore, electricity immediately after generation is stepped up to a very high voltage using a step-up transformer. Since the number of turns in the secondary coil in the step-up transformer is more than that of the primary coil, the output voltage is very high. At the consumer end, it is stepped down to a suitable voltage before being supplied to the household. Note that the number of turns of the secondary coil is smaller than that of the primary coil. Therefore, the output voltage in the step-down transformer is lower than the input voltage. The lower voltage increases the current so that it is sufficient to operate household appliances. What kind of electricity is used for power transmission? Alternating current is generated. This flows backwards and forwards around the circuit. In India, domestic current is supplied at 220 volts with 50 Hz, that is, 50 cycles per second. In other words, AC flows backwards and forwards 50 times per second at 220 volts. Two wires are required to supply AC current. They are live and neutral, collectively called mains. Alternating current actually flows in the live wire. It becomes positive and then negative 50 times per second, or to put it another way, it changes its polarity 50 times per second, hence alternating. Contact with a live wire is usually dangerous and is fatal also. The neutral wire is the wire connected to the earth at the local electricity station. Though current passes through the neutral wire, its voltage is zero. If someone comes into contact with a neutral line, they do not experience a shock. Electric power is supplied to the public through the mains. The main cables are supported by overhead electric poles or by underground cables. There are color codes that are generally followed to identify the type of wires. In domestic connections in India, red indicates the live wire, black indicates the neutral, and green represents the earth wire. The European Union color code is brown for live, blue for neutral, yellow and green for earth lines. The potential difference between the live wire and the neutral wire in India is 220 volts. The meter board has a main incoming fuse in the live and neutral wires. They pass through the electricity meter via a main fuse. The meter measures energy consumption in kilowatt hours. Mains wires and household circuit wires are connected through the main switch. The earth wire with green insulation is connected to a metal plate and kept deep in the earth near the house. The metallic body of an appliance is connected to the earth wire, which provides low resistance and conducts any leakage of current. The user is protected from a severe electric shock. There are two systems used in household circuits. They are the tree system and the ring system. In the tree system, in each separate circuit, different appliances can be connected across the live and neutral wires. Each has a separate on-off switch. Each appliance has the same potential difference, hence they are connected parallel to each other. The electric fuse is the most important component of domestic circuits. The fuse prevents damage to appliances and the circuit due to overloading or short circuit. Main switch is of the double throw type. It makes or breaks the contact with live and neutral for additional safety. From the main switch and fuse box, the wires run to the distribution board, where the wiring branches off to the sections serving different parts of the house. Each branch has its own fuse. If any appliance fails, others still continue to function. All switches are placed in the live wire. This makes the appliance neutral when the switch is off. Sometimes, when touching an appliance, a person experiences a shock. This happens when the metal casing of the appliance is in contact with the live wire. The ring system is another system of wiring. Live, neutral and earth form three separate rings around all the rooms in the house. Appliances can be connected to the ring circuit in parallel. Advantages of ring system. It's easy to install new points. Current reaches an appliance along two different paths. Only half the current flowing through an appliance is carried by the main cables. So thinner cables of smaller rating can be used. The length of cable required is smaller, so it is more cost-effective.